It's a free implementation of Smalltalk language. It's a fork of Squeak. That was done in the early 90s at MIT before teaching for research. As you might know, in Smalltalk you develop in an image, and the image includes both the programming language and a full ID. It's object-oriented, dynamic. There is a lot of reflective features that permit you to introspect the state of the objects and doing a lot of powerful stuff. And so it's a kind of development called live programming, because you really develop the program while it's running. You can do that. Okay, so it's a multi-license, it's free, blah blah blah. All that is related, following numbers, so that it's advertisement. Okay. In Smalltalk, Smalltalk is an object-oriented language, but unlike other object-oriented language like Java or C#, everything is an object. So classes are objects. They are just special kind of objects. Methods are objects, special kinds, but still objects. So everything happens by sending a message to an object, and that's all. There is nothing more. Yes, no constructor, no static methods, no operators, no interface, no private protected modifier, no boxing and boxing you might find in Java, no parameterized type, no type declaration, no type at all, in fact, and etc. Everything is an object, as I said. So objects are instances of class. So you can add this class of an object by sending it the message class here. So if I ask class to the integer 213, I got the class small integer here. So it's a message sent to the object 213. It's really an object, it's not a primitive type. So in Java it corresponds to this expression. So here, small diagram, we have the object that is an instance of small integer that inherit from integer, and the inheritance change go up to object. So when you send a message to an object, so say I'm sending a message factorial to this object, what is the algorithm to find the actual method to be executed is the following. You go in the class that is small integer, and if you find a method that corresponds to factorial, you execute it, else you go in the superclass. So quite the same thing that in other object-oriented languages. So classes are object too. That means that you can send messages to classes. One example of such messages is selectors that will give the set of all method names. The selector is in Smalltalk we call selector is the name of a method. And so if you ask the class of 213 for all these selectors, they will give you all the kind of stuff you can send to an integer.
That's array?
Yes, that's an array of symbols. Selectors are just symbols, just like a string, but unique in the system. So you can send other kind of messages. So I can send the message also classes. So to number, and I will get all the kind of numbers, so fraction, float, integer, skull, decimal, etc., etc. So fun with numbers, what it is. Okay. So if I ask one's class, I get a small integer. If I ask this class what is the max value, a small integer can get it. So typically, you can implement the equivalent of the Java static method as method of a class. There was the instance side that are the list of messages that the instance of the class understands, and the class side where you can implement methods for the class. So instead of having a special concept of static method, you just have a method, but it's not the object that transfers to it, it's the class. So plus one, okay. So I plus one. That's to see that everything works seamlessly. And if I add the class of this number, I got large positive integer, so everything works just perfectly.
Is this size of small integer machine dependent, or is it always?
No, it's always 31 by bits.
Yeah, because the VMs are 32 bits.
Yes.
Yeah, when our VMs will move to a 64-bit architecture, probably the small interrupt will be even bigger.
Yeah.
Will be 60 or 62 bits. 62 or something like that. It depends on how many
flags you use.
Yeah.
Okay. So yeah, so it's 31 bits right now, but you don't really care since everything happens transparently. Just you don't care. You see, you don't have nothing to handle. Just normal messages. Okay, so that's the object 1, and I send a message slash and the argument 3, and that raise a fraction object, and it's not decimal, it's really a fraction, and if I took these two numbers, I add them, I get 1, and that's a small integer, so you get automatically casted to the product class.
And if I leave parentheses?
So there is an order of evaluation, and there is a slide after for that. It depends. So
not multiplication before.
No, it doesn't work in Smalltalk because it would require extra syntax, and Smalltalk's one of Smalltalk better assets is to have a really simple syntax, really simple grammar. It's been said that Smalltalk syntax fit in postcard. Okay, so if you add an integer, you will get a fraction back because you cannot round it. And 1000 factorial, you get a large positive integer, and that just works. Nothing.
Is there no limit?
As you see in that example, you start having a lot of zeros at the end.
That's normal.
I don't see the number, yeah, because it's a factorial of 1000. But at some point you start losing, for the factorial I don't know if you lose.
No, it just
when you do multiplications, yes, you are safe. But when you're working with floating point, you lose.
Floating point,
you lose precision, as always.
Classical floating point, of course. But for large positive integer and large negative integers, there is no problem. You're just limited by the memory.
And speed.
And
sometimes.
Speed, yeah.
The bigger the number, the bigger the calculations you do.
Okay, so classes are object 2 still. So if classes are objects and objects have classes, that means that a class must have a class. So if I send the message class to the class point, I get the result, and that's a so-called meta class, and it's anonymous because its name is just the same thing as the expression that returns it. It's self-evaluating, but that's the name of this meta class. Each class has its own meta class. So it has only one instance, the class point, and that's the class where you put the method that the class should respond to. So for example, if you set the class to put the equivalent of static Java static methods. Okay, so here we see that we have small integer, that's an instance of the meta class small integer class, and integer that is so you have parallel hierarchy there. Okay, just like I said, the static method is just a method of the meta class.
With one benefit is that static methods in Java are not inherited,
Yes.
while here they are looked up as in the normal methods.
Yeah. And in fact,
So you can share.
the lookup algorithm that I showed you earlier just was the same. You send a message to class, so it go fetch its class and see if the method is there. If it's not, you go in the super class, and so on and so on. So it's not a special case. So class extensions. Have you done a bit of Ruby?
No.
Do you know this concept of monkey patching? So it's
Bad idea.
It doesn't sound good.
it doesn't sound good, yeah. But that's still a feature. The idea is that say you have you use a library that you don't develop yourself, but there is some classes that you use in your system, and you can add new methods to these classes.
Overriding.
No, because you don't have to subclass the class that you use. That means that the very same object. So say, for example, that's an example. So $x, that's a character object, and so there is that's yours.
Yes.
So that's a library for writing shortcuts, and this message CTRL is implemented as a class extension. That means that it does not belong to the same package as a class character that is in the core system, yet it is installed in the character class. That means that if I unload the what's the name?
Key mappings.
Key mapping package, this method will be unloaded from the class character, and when I load it, it got automatically loaded in the character class.
So that means that you can extend the core classes of the system. You can add methods to the strings, to the numbers, and yet not make dirty the system.
And Object Studio, it's called secondaries. It's a secondary file. In Object Studio, I know it as secondary file.
It's very powerful, but it's also has some problems because the order in which you do things might influence what you can do with that. If I add two extensions and they have the same name, then
the last one loaded
wins.
wins.
Okay.
Yeah.
Yeah. We are thinking about some solutions to this problem. Okay, so that's pretty useful. We will see an example after.
The problem with that is also that you cannot add instance variables in that way. Just methods.
Yes.
Yeah. So it works very well if you have a dictionary somewhere in this object where you can then, through the methods, just put things. That's what is often used in Magritte, for example. And if you want to add instance variables, you are lost.
Yeah, because that would mean that the format of the object would have to change every time by marshalling and marshalling when you go in the package. So it would be really complicated. But yet it's quite useful. Okay, so summary. Everything is an object, one single model, class is object 2, the class is an instance of another class, called a meta class, one unique method lookup, so don't matter if you talk to a base object or to a class object, just the same lookup. Okay, so now the syntax. That's just example to show how easy it is to build DSL in Smalltalk. So here that's just plain Smalltalk syntax. There is no sugar. There is no sugar here. Just plain Smalltalk syntax. Yet you can see that that's really reads like a kind of assembly language. That is another library used to write parsers, and so if you can write things like that. So that sharp is for symbols. So you say to the symbol letter as parser, comma, word as parser star, so that recognize normal identifier in most programming languages. So that's just a plain Smalltalk syntax. So this as parser is a class extension, like we talked earlier. So the parser library adds this method to the class symbol, and like this you can make a really a syntax that is really easy to read. Okay, so that's postcard. Here you have everything, every syntax element of Smalltalk. So that's the method header with the selector, an argument. That's a temporary, so you must declare temporary between pipes. That's true, that's an immediate object, false. That's binary messages, unary messages, we will see it's different just after. Binary messages, unary messages. That's block. So as Stefan showed in the whiteboard, that means that this may not be executed. Likewise, so that's an assignment. That is a dynamic array, and that's a literal array. The difference being that you can put expression inside a dynamic array, and they will get evaluated to raise an actual array, while a literal array can only contain literals. So that means that here I can put a full expression, it will get evaluated at one time. So blocks again, so that's the way we do iteration in Smalltalk. So here is an array that contains three elements, first being another array. You send the message do, and you give a block, and block can have arguments. So here it's an argument that begins with a column, and then you have a pipe, and then you put Smalltalk code. And that means that for each element of the array, this code will get executed. So blocks are similar to first order function defined in functional languages called closure.
The cascade also.
The cascade, yes. So that's a special syntax element. Sometimes when you want to send several messages to the same object in another language, you will repeat this object in several expressions. So you say, my object do this, my object do that, my object do that. So there is special syntax Smalltalk for that, and you say, my object do this, semicolon, do that, semicolon, do that, semicolon. You can chain a list of messages. If I go back to the DSL examples, here, that's what it's used here. So ISM is the receiver, and that's a set of messages with so that's an easy way, and it's quite useful to write code that is.
So there's one question. If I have object and send a message and another message, and example, is it always the last
Yes.
object that will be
Yeah.
send the message to every time I
Yeah. So if
use
you say
semicolon?
So if you say an object messages messages 1 colon message 2 colon, the messages 1 and messages 2 will be called on the result of an object messages. It's like if you have put in parentheses one, but you don't need that. Okay, so language construct. This caret symbol is for return. So in the old times, it was represented as up arrows in text editors. That double quotes is for commands. That's for symbols and arrays when it's literal arrays. Single quotes are for strings. That's for blocks. That's expression separator. So like semicolon in Java, you put it between expression. You don't have to put it after the last one expression. This will be a separator like in Pascal. That's a cascade. That's a pipe for declaring temporaries, either inside a block or for method. That's the assignment, and that's for characters. And that's a special thing for annotation in methods. So you can put custom annotation in beginning of methods between comments.
And what is the difference between annotation and comments?
So the comments is just plain string, and the annotation can be computed and fetched by the environment. So you can create your own annotation, and you can then make a tool that will gather all the methods that are annotated with that. This annotation can take arguments, can do a lot of stuff with this mechanism.
A comment is just ignored by the compiler. So when you get the method object, you cannot ask him the comments. What you have to do is actually to ask him the source code, and then you parse yourself and get the comments. So, but the annotations are part of the metadata of the method object. So you can query it and do stuff.
The comment, do I have to start and end, or just?
Yes, it started, and you put some comment between double.
Yeah, because I saw in our company code that I have always in the start double comma, and on every line, in the beginning and on the last, there was an end.
Yes, it supports. I don't know. In far at least, it supports line. How do you call it? Yeah, you can put enters, breaks, line breaks, bit, and it will work. So you can put a double quote up there, up here, and close it below.
Yeah, but there were in between.
No.
Yeah, it means that there are many comments. Those are many comments, and you can put a comment wherever you want. The compiler and the parser will just ignore them and.
So, examples. So that's a command, that's a character C, that's a character dot, some strings, some symbols. So symbols are just like strings, but they are unique in the system. That means that if I evaluate twice symbol Mac, I will get the very same object. While with strings, you could have difference of any difference. So it's used as an identifiers most of the time. Array, so that's a dynamic array. So as you see here, you have an expression with an addition of two integers. So that will raise an array with 1 and 124. Okay. While that's a literal array, and it contains only literals. So 1, 2, 3, another array. So you don't have to put the dash inside because you're already inside the literal array. Okay. That's a special one, bytes array. If you want, if you do some low-level programming, you may need byte arrays, so just an array of bytes. A block, so that's a lambda expression that perform that multiply some integer by 2, some number by 2. Integer, so you have one, and you can have a special syntax, so you can put a number R and a sequence of digits, and the 2 here means binary. You can have ternary and or octal if you put 8, etc., etc. Or hexadecimal with 16 R.
And the letter is always R, or is it
What?
the letter?
Yeah, it's R. I don't know.
In other languages, it's sometimes X.
Yes, normally it's 0x or something like that.
I don't know what the R stands for.
I don't know.
So, likewise, you have reals with different syntax too. So you can have this scientific syntax, and that's all. And so keywords. Oh, that's an error.
Yeah.
So in fact, there is just 3 keywords.
Yes.
So the last one. These are just objects. Just
Literal.
literal objects. True, false, and zero. The real keywords are this one, so self, super, and this context that is a bit special. I don't know if we're going to see it in detail. So not syntax, all that are just message things, that's not syntax, just the name of a method. Any class can implement that, these messages. So example, magnitude implements lesser than. So magnitude is for a thing that can try to present some range of values. Collection, do, etc., etc. So the 3 kind of messages. That's the important part. So as I said, there is unary messages that have no arguments, like factorial, or here current return and transcript. You have binary messages, so they take just one argument, and they are the syntax of this message are all the symbol, mathematical symbol, and combination of those. And keywords messages that can take one or more arguments and are so the selector of this method is between and the arguments are 0 and 5, and you put the argument in between. That permits to have a more natural way of reading code. The same thing in Objective-C, I think.
In Objective-C you can do that. Actually, part of its syntax is inspired in Smalltalk.
Yeah.
The Objective-C one.
Yeah. So that might seem weird at first glance, but it's really enjoyable once you use 2. So 2 between 0 and 5 will return true. And in a lot of so that's an example that syntax you would find in Java, for example. Postman, send, mail, recipient, and what you do for in Smalltalk, first you remove all the extra stuff, points, comma, parentheses, semicolons, remove them. You put some word to complete the selector, and you just put colons. And you have postman, send, mail to recipient. But it's much more readable, I think. So the receiver, the message sent, the first argument, second argument. What is that? So some comparison. So that's for comparing with Java, but it's not really important. This one is cool. So that's an iteration, special kind of iteration that collect the result of the block and create a new collection out of it. So the way to do that in Java is that you first declare a new array list, and then you do an iteration on it to add the name of each person to this list. In Smalltalk, just say small persons, collect, and you give a block that will get related for each element, and the result of the block will be used to create a new collection. You can use this shortcut because symbol respond to value, that is the message sent to blocks, because blocks are objects. So that's just a little trick. If you put name, you would just send the message name to each of the elements. So it can be even shorter.
That's firewall special, or is it, do you know if it's also Object Studio?
I don't know.
I think it is for a special because we installed it not so long ago.
Yeah.
But actually you can install it where normally all the Smalltalks you have the source code there and you can add the method in the symbols.
So if you want to have it, if you want to have this trick in other Smalltalk, you go in a symbol class and you implement the method. And that's the way to say. That's not Smalltalk syntax, but that's a common way to say in which class you are. And you implement value colon with arg, and you return arg perform. Perform will execute the message. The message with symbol is given in argument. So here you're in a symbol, and so if you send name, value, person, that's equivalent to a person name. And since this message is used for evaluating block in iteration, everywhere you use a block for iterating, so there is not just only collect, there is select, reject, a lot of iterating methods that you use in any selection. If you implement just that, you can give a symbol instead of a block. As soon as you just make just one message crossing the content. So you have a small performance penalty for that, but it's still fine. Okay, so that's for creating a new thread. You send a fork message to block. That do something. Fork the equivalent Java code.
No, I did a lot of Java in the last years.
So yeah, it's much shorter. Okay, so now we talked about we've been doing keywords message, so there is an order of evaluation, and it's this one. So first you evaluate what is inside parentheses, of course. Then unary have a higher precedence than binary messages, and binary messages have higher precedence than keywords messages. That means that here the order of evaluation is first plus, send it to 20, reading 22, then it's between n, and finally it's not. Okay, so 10 between 1 and 22 not, it's false. Okay, because it is. Okay, so that's method definition. That's how you define method in the environment. So that's the name of the method. Here it would be a binary selector. The argument, the command, the return, that's an instance variable, the class point, binary messages, keyword messages, block, and in book and slides specify the class name, so it's not correct in Smalltalk syntax, but that's just a joke. So in mails or you will see this syntax used. Okay, statement cascade. Talked about it. So here pen, you can send several messages to the same pen object. So up, go to P, down, go to P plus P, it's kind of logo, like the logo language where you have a turtle and you could draw stuff. So that's quite the same system.
One question?
Yeah.
But I have to set the point at the end, or is it on the last statement behind the P plus P?
Behind the P plus P,
No,
yeah, no, you don't need dots because at the end of
End of the message and then.
yeah, yeah, it just dots are just to used as a separator between expression, not just it's not like a semicolon that you have to put at the end of each expression in Java. It's more like a semicolon of Pascal, just between, but you can put one if you want. Okay, so blocks, we talked a bit about it. So that's another example. You can have several arguments here. So just one. So if I say value 2, I get 2 times 2 plus 3. Okay, so 7. So I come back to the order of evaluation.
Forward. There.
Yes. So what does that mean? That means that all unary messages have all the same precedence. So you have to, you don't have the mathematical precedence for operators. So that means that if you evaluate 1 plus 2 plus 3, you don't have 7, you have 9. Because this is evaluated first, is like writing this. So if you want mathematical precedence, you have to put parentheses. So you have to be aware of that.
And why not? Why?
Because it would imply to make a special rule in the grammar and saying that this selector have higher precedence than these ones, and that would complexify the language in the end. And in the Smalltalk philosophy is to keep a really simple core language.
For speed?
Not for speed, for people to get it really fast, because you can really understand the internals of the language quite quick.
Yeah, actually, it's not about speed, because if you actually build a rule to put the precedence, the compiler will actually, the only thing it will do is to put the parentheses. So actually, it will be maybe a little downgrade in compilation, which doesn't happen all the time, and since the unit of compilation is a method, it's always quick.
And you build new methods, and if you have this one has a higher precedence than this one, and if you are building new one, you have all the ways to say, oh, this must be before.
If you change the precedence, then you have to change it for the whole system. That's one thing. The other thing is that the message plus there is sent to a number. But you can actually implement the method plus in any class you want.
Yeah.
So you can actually create your own operators in your own classes to combine your own things. Let's say that you are building a thread library, and then you want to run 2 threads in parallel, and then you say, okay, this thread plus this thread run, and that runs the 2 threads in parallel. So if you start adding rules, you make the whole environment more complex.
Yes, yes, yes. Yes, I understand.
So it's a bit weird at first, but you just have to know it. So that's Smalltalk image. So an image is a file that contains all the alive objects of your system. That includes the whole language, the whole IDE, and the stuff you're developing in it. And that means that you can save at a certain state, and when you reopen it, you will get exactly the same state with the same windows open at the same place, etc., etc. So the development is quite different than in other programming language because it's not file based, it's image based. You're not manipulating files and directories. You can, but that's not the way to develop. Instead, you develop inside these images, and you just create new objects that are classes, and you just save an image, and that's all. So that's the first tool to know about. It's called the browser, and it permits to browse all the classes of the systems. So, for example, you have this panel contains packages, so you can select packages and see methods that are in it. This panel is for protocols. It's just a way to put methods in so accessing, processing, another one, initialization, just a way to tidy up things. There is no semantic behind, just to keep things tidy. And then you have the method, and when you click, you can see the implementation of the method here. That's just a getter, and that's basically what you do in a browser. Another important tool is the workspace. So workspace is just an editor when you can write and evaluate some code. So I can evaluate the stuff I wrote written in the slides. So there is shortcuts. So for example, print it will evaluate the expression and print the result. Do it will just do it without printing. So the shortcut, so it's Command P. Press Command P as that, and I can resend a message. So on and so on. What you can do also is inspect an object. So that's quite useful. What kind of object can we inspect and
the selectors of the class small integer, maybe?
Okay, so small integer selectors, so that gives big array, and I can inspect it. So that's an inspector that permits to see what's in this array. So likewise, I could inspect, say, a point. So that's not special syntax again, that's just a message sent to an integer, such as a point. I can inspect that, and I see that I can see the current state, and I can change it on the fly. Points are immutable.
But you can change it.
In Spark.
Or x equals. You can not assign.
Yes.
Yeah, you're in the inspector. You can.
Yeah, I'm in the inspector, so I can assign. Yeah, because I'm evaluating the expression in the context of the object. So it's just like, so if I do that, see, state of the object changed, and that looks like nothing, but while you're developing, having inspectors is really, really useful, because that means that while you debug something, you can open inspector, navigate through object pointers, see what is the state of this one, it's really, really useful. And the last tool is a debugger, and there is Faro developers that, Smalltalk developers that develop mainly in the debugger. They develop in the debugger, not just debug. So we can make a little example of some TDD basic exercise. So we create a package tutorial, and in this package, so here it's a template for creating a new class, but again that just no special syntax, just objects sent to messages. So for example, there is a class called testCase that respond to all class objects respond to this complex message used to create a subclass. So I will say person tests. Okay, and I just evaluate this. I got a person test here. So I will create my first test. Creating a person. So here I just write some code. So named
Camille.
me, okay, it's me. And now I just save it. So he asked me my name, it's just for putting a stamp on the method version. So that's me that did it today. Okay, so the compiler is not happy because it doesn't know person, so it proposed me to define a global, a class variable, or a class. I choose class. Okay, just a subclass of object, has no instance variable, nothing special. Okay. And now I run my test. I got an error. The error says that the class person does not understand name. That means that the meta class person class does not implement name. So what I can do here is click this little create button, create the missing method, and I say I want to create it in the person class. I can provide a protocol or category. So let's call it instance creation. And here it opens the debugger opens on this newly created method. So the different implementation itself should be implemented. That way is an error. This method should have been implemented. And I will return self new. So self here is a class.
Inspected.
Yes. You can inspect it.
Yeah.
So you can evaluate things inside the debugger while you debug. So here I say okay, a person. Okay, I will set his name to a string. I use a colon, and I return yourself. Yourself is a message